We're interested in calculating the integral of arcsine or inverse sine of x to the second power dx. So let's see how we can resolve this evaluation. Well, we're going to use the method of integration by parts. Integration by parts. And remember that when you have the integral of u dv, it's equal to uv minus the integral of v du. So what should be my u here? Should I take the whole thing arcsine of x to the second power as u and then dv dx? Well, we're going to practice. We're going to try our best. There is no definite way. So let us take u to be arc sine x to the second power, and then dv, we just dx. Let's see what we get. So to calculate du using chain rule is 2 times arc sine of x to power 2 minus 1 times the derivative of arc sine x. And then on the other side, v is equal to integral of dx, or v is equal to just x. So let us go back to du. Du so far is 2 times arc sine of x, and the derivative of arc sine, as you remember, is dx divided by square root of 1 minus x squared. Well, okay. Now let us go back to our integral itself and try to split this using integration by parts. See what do we have. So this guy is equal to uv. Okay, u is nothing but arc sine x to the second power, and v is equal to x minus the integral of v du. V is x, and du is 2 times arc sine x dx divided by square root of 1 minus x squared. Well, okay. I'm going to try my best to calculate this integral. I'm going to use substitution. So let me write this guy down here. In calculating the integral of x times 2 arc sine x dx divided by square root of 1 minus x squared, I'm going to try my best to see if I can simplify this further. If t is equal to arc sine x, we know that dt is equal to dx divided by square root of 1 minus x squared, which we already have, all right? But what happens to x itself, right? So since t is equal to inverse sine of x, x is sine of t. Very well. So this integral can be written as the integral of, instead of x, I'm going to write down sine t. And then here you have 2 times arc sine, which becomes 2t. And then I have dx divided by square root of 1 minus x squared, which is just dt itself. Very good. So this integral became a simpler integral this way. So I'm going to just make it a little bit easier to read. So wherever I see x, I'm using sine t. Wherever I see 2 times arc sine of x, this becomes 2t, and wherever I see dx divided by square root of 1 minus x squared, it is just dt. This guy is just 2t and the rest. And for this integral, I can use integration by parts again. So you are applying integration by parts twice. So far, this integral became x times arc sine x to the second minus the integral of, here you have sine t, 2t dt. So for this guy here, I'm going to apply integration by parts. Again, apply integration by parts for the second time. Okay, very good. It's not that difficult. I'm going to write this guy down here and show you what to do. So let us take u again to be like, I'm going to write down 2 in front of the integral. I'm going to take t equals to u, and then dv is equal to sine t dt. So my du becomes dt, and v is nothing but negative cosine t very good. So this integral can be written as, so I'm going to rewrite the whole integral again, x times arc sine x to the second power minus uv. I'm going to use bracket here. And don't forget you have a 2. Okay, so minus, I'm going to write 2 in front of the whole thing to avoid any confusion. Okay, minus 2 bracket uv, which is t times negative cosine t minus the integral v du negative cosine t dt, and close up bracket and calculate this integral. So far you have x times arc sine x to the second minus, well, I have negative 2, and you have 2 negative signs. I'm going to, for now, copy down these with different colors because eventually we have to rewrite these in x. You cannot leave it with t, and you get, so you have 2 negative signs, another negative sign is outside, you get negative 2 integral of cosine t and dt. But the integral of cosine t is nothing but sine t. So far you have x times arc sine x to the second plus 2t cosine t minus 2 sine t plus c. Well, okay. I know that my x and sine t are the same thing, so I don't have any issue with sine t. Sine t is nothing but x itself. But what should I do with t itself and the cosine t, right? So let us go back to our right triangle. Remember, when you had a right triangle and you have an angle like theta, based on the definition of sine t or sine theta, which is equal to your x, you can decide about the values that you have on each side. So t and theta are basically the same thing here. When you write down sine t equals to x, it is basically x divided by 1. So this quantity is x, this quantity is 1, and this length is 1 minus x squared. So you can use this to define cosine t or cosine theta. This guy is equal to square root of 1 minus x squared divided by 1, or cosine t is equal to square root of 1 minus x squared. Perfect. And for t itself, since you already have, let me just go back up here and show you what was the definition of our t. T is equal to arc sine of x. So you're going to just substitute this guy down here. Very good. So our integral is x arc sine x to the second power plus 2 times t, but t is arc sine x times cosine t. Cosine t, I found cosine t just right here. So plus 2 arc sine t times square root of 1 minus x squared minus 2 sine t is x itself plus constant of integration. Ooh, a lot of work. We applied integration by parts twice. And we use the definition of arc sine, arc cosine to find the solution for this integral, to evaluate this integral. So we applied integration by part once on top. We broke this guy down into the integral of sine t 2t dt. But for the integral of sine t 2t dt, we have to apply the integration by parts again. And this is the final answer.